Welcome to a new episode and video on my Raspberry Pi 2 right here with serial cable attached to the serial Pi Plus board, which is stuck upon the Raspberry Pi 2 itself. Not good visible from this point of view, but an HDMI cable connected to this monitor. Standby currently. Then not visible but hidden is a network cable for VNC and some updates, etc. Then of course band cable, which is connected to the breadboard with some electronics and a little bit of fischertechnik, and a motor that I still have to attach, which is this one. This propeller. That is the monitor and the camera with microphone that you use for my screencast, and extra an old MacBook which is currently also on VNC. So it's not the fastest computer, but we'll see how it works out. So this is number 4, which means there's a number 3 as well, and that may be a familiar view because that is this Android tablet, which gives a problem still when you try to exit or control C and program. That I don't expect that to have with the MacBook, but who knows. Anyway, time to connect the motor, and for being safe also doing the GPIO test. You never know what's going wrong. Then of course with band cable all wires which are currently attached, apart from this one, but that is not important right now. Most important is that these LEDs work, this LED should work, this motor should run nicely, and what I want to test is if this one works. Will it? I don't know. That's what the test is for. So, let's first from the Mac run the bash command. So right here I have now over the terminal with bash etc. Bash space GPIO.txt. So I give enter, and I already see some things happen on the breadboard. So let's take a look there. I see no output on the terminal, so let's do it again. That was a quite short flash, but now I do have the familiar right arrow device or resource busy output. Staying on. Ah, there this one goes, and this one stayed on came on as well. Let's do it again. Running, and running. And this should be for 5 seconds, so that is quite alright. That is nice. So, by now I know that the hardware works, but last time I also had a problem with the compiler. I found out that I might have to use a newer compiler. in order to use the GPIO on C++. I installed it, but I couldn't use it yet, so I have some work to do. Anyway, let's see how things go on from here. Alright, so now it's clear that the bash script runs. It's not clear yet that the ROS runs, so let's start. Excuse me. Oh, right. Yeah. Because I have included GPIO class, I haven't recompiled it, so it won't run. Point taken. Just like last time. And this is a matter of compiler. So from here, when I say I have to be here, catkin make, I can see everything happen, and usually, oh yeah, that's right, I usually do that from the third terminal, which I haven't opened yet. Right now I have, and then source developer setup .bash. Now I'm in. In the meantime, I have to actually still check if the compiler is indeed the culprit, which I think it is. Now I need to check this one, and this is 4.5, and I need a last formal one. So how to check on that? Probably like this. Username GCC, yeah. There it is. The question is, how many are there? So I am going to user bin and check for listing, which means more details on GCC. GCC points itself towards 5. Then how many are there? And there we go. That is GCC 4.8, which I installed last time. And if I just call it, it is 5. Which implies that I have to point CMake to use 4.8. So that is something I will have to find out. Oh, by the way, I have, except for the both desktop from VNC 1 and 2. 3 is the tablet that I've shown you, and the 4th is then the resolution, with resolution for the Mac that I showed you, the MacBook, as a short explanation. Now it's up to finding a way to point catkin make to GCC, the correct one. I found a possible way to manually control the version of the compiler that I'm using. So in here, after an example, I found catkin make space what do you call that, hyphen D CMake. D is decision, CMake C compiler is 4.8, which is here, which I installed last time. However, this is not C, it's C++. So I have to do the same for C++, which is indicated just like here. CXX compiler is, and then I see that the C++ compiler is only this one. Ouch. So now I need to find out what I actually did install last time. It is the ordinary C compiler, so I probably need to install G++ as well. Let's see that one. Yep, there it goes. Hopefully that's enough. But I will find out soon. On the other hand, the example didn't give a C++ compiler, but CXX is C++. So let us just do this. And this is G++ and 4.8. Let's see what the result is. It may be disastrous, it may be good. Experiments may fail completely and yet have a successful come out, in the sense that you know what has gone wrong. See, it takes the other compiler. So now I'm very curious if I will end up with a working GPIO class. Or not. One message, one service. Well, that is good, because it is. Warning, warning. It's building. Something is being built. Will it? Will something actually do work? So far, so good. But then again, linking executable. Oh, perfect. Oh, no. Oh, this goes wrong. Where does it go wrong? Ugh. Oh, this goes all wrong. Unfortunately. A reference. I have to find this out once again, and it is about GPIO class, no doubt about that one. In function control ft callback undefined the allocation. Really? Undefined unsigned reference in, I can't even read it. Anyway, this is not good. So I may have to find out to disable this whole block again and see if that compiles this one, because now it is referenced to callback, which it did not do before. Ouch. Alright, so back with the next step, which is to find out if it works, if something works. Where's my cursor? There. So that's one end of the block, and that is two. Yep, everything commented out. Redo. And this may be boring, but it is the only way to find out if here with ft callback, which they mentioned, is really wrong. I don't hope so. I don't think so, because without the GPIO class it ran nicely. Oh dear. Forget about it. Forget about it. Okay, so I have cut it out. What I'm now going to do is just catkin make. No parameters given, just catkin make. So now it takes the version 5 compiler. Hopefully this does the job good, or well enough. Otherwise I'm in trouble, more trouble than I thought. But let's not run ahead of whatever is happening. Uh-oh. What is this? Okay, wait. What I'm going to do is changing this to GCC, because GCC and G++ refer to version 5. So if I put it now this way, I hope it goes right, because then 4.8 is a very long compiler for it. Okay, see, I am changing the compiler version. That's a good lesson. Changing the compiler version and changing back needs both the changing parameters. Never assume anything that happens automatically. please do. Please compile correctly. And if this does, I may have a bigger problem than I thought. Because of the simple reason that this is not compilable with 5, and this is apparently not compatible with 4. So it's either one or the other, and I don't like that at all. But we'll see how this linking goes, and it finishes. Alright, now let's run. Control. And where am I with my, oh come on, I need to run my ROS, run Raspberry, of course, yeah, and FT motor. Excuse me? How come there's no FT motor? Control. Can't find an executable. There's no executable for motor and no executable for control. Hold on. Okay, now this goes wrong in all the way. In all possible ways it goes wrong now. I'm now compiling with 5 again. No arguments this time. Generating done. I'm fine. I want my executables back. If this ft underscore m autocompletes into motor, I have my executable. If not, I have a real big problem. Build target FT control. Good. So, yes, this is control. Motor, very good. I have them. I have them both. Running. Running. This has a very big conclusion, which means that 4.8 is incompatible with this stuff somehow, while 5 is still incompatible with this stuff. And this is running on my other Raspberry Pi, which runs an older version of Linux with an older compiler. So I really need to check out which compiler it is, because I kind of gambled to 4.8, but now I really need to check that out. This is far from funny. Alright, so I am still bound to the GPIO to get some action done. And mind you, I'm still working on the Raspberry Pi itself, just via the VNC as I record with the screencast. So this is obviously my Android tablet, and this is bash.gpio.txt. So whenever I press it, and let's see if I can get both inside. Yeah, let's press enter then. takes 5 seconds, and then it ends. So let's do it again. So that works just like it did with the MacBook. It is a simple script, and it just takes 5 seconds, so there's no need to do Ctrl+C here, which I still am not able to do. But other than that, unfortunately, I can't show. So the whole reason that I am now in trouble with the compiler, I didn't expect that, because my first experience with the robot operating system was using C++, and all was fine. But it's several years later now, and guess what? Something doesn't work. Anyway, to call that dependency hell, I wouldn't think so, but I hope it doesn't become so. And a dependency hell is a situation where you want to compile something manually or automatically, and suddenly dependencies like libraries, etc., are suddenly incompatible. So you are finding yourself with a lot of problems, libraries and other programs that you depend on and don't have. End of story. A lot of times. Anyway, thanks for watching. If you like this video, please subscribe to my channel. Give it thumbs up, the video that is, and leave a comment or suggestion. Please also be so kind to make a small donation via PayPal or Wired. And you can also become a patron, have your name mentioned on my website, and depending on the pledge you make, also with my videos. This is obviously going to be continued. All information, including the URL to my website with lots of information, other projects and pictures, etc., are under this video. For now, have a great day or great night, wherever you are. To be continued, and bye bye.